Well, hello, everyone. My name is Raphaël Pinson. I am an infrastructure developer and DevOps enthusiast. I've been using Puppet for roughly 13 years and have mainly focused on file editing with OGS. I'm also involved in the Puppet community, Vox Populi, since the foundation. And you can find me on the internet under the name Raphaël. I work for Camptocamp, which is an open source service company based in Switzerland, essentially, with also offices in France and Germany. And as part of our work in the infrastructure department at Camptocamp, we've been working on automation for years, working on cloud automation, working on systems automation with Puppet and other tools, working on config management, containers, observability, as well as web, application deployment, more recently with Docker containers and Kubernetes, for example. And so we've been involved at Camptocamp since 2007. I wasn't there yet. I'd actually joined Camptocamp through Puppet in a way. And we've made many modules on the Forge and even more on GitHub that are not published on the Forge. And we've been involved in Vox Populi, in OGS, and we've been Puppet partners as well. And so through our use of Puppet throughout the year, we started a few years ago to automate deployment of modules on the Forge using Travis CI, using a CI/CD approach. And so it's kind of a standard CI/CD approach using continuous testing and using Docker as a replacement for Vagrant and OpenStack to run the test, in particular the acceptance test using Beaker. So this was the first approach that we had in using Docker actually in our team around, I would say, 6 years ago when we started using it to automate acceptance tests for Puppet. But then, as you know, the Puppet stack can be complex. And when you're deploying the Puppet stack, in particular the open source Puppet stack, there's many components with many dependencies. This is the state of our Puppet stack about 6 years ago. It's got tools that we don't use anymore, like mCollective, but even then, there's still a lot of things that get together in the stack and that need to interact with each other. So there's many components, many dependencies to deploy the entire Puppet stack. So if you've tried deploying it yourself, if you try to make a deployment of the open source stack for Puppet, you know it's hard to deploy, it's hard to automate, and there's a problem of order. In particular, when you take the Puppet DB and the Puppet server, for example, do you start the Puppet DB first, but then how do you provide typically certificates from the Puppet CA if it's not up yet? Or do you start the Puppet server first, but then how does it connect to the Puppet DB? It's a little bit easier nowadays when you can have optional connections to Puppet DB, but it's still a rather complex problem to solve. So in 2015, there was the switch to Puppet 4. That might seem a little bit far back for some of you, but since we've been in since Puppet 0.23 roughly, Puppet 4 was an important switch for us for several reasons. One of them is that Puppet switched to what was called all-in-one packages, AIO packages. And all-in-one packages meant that everything was reorganized inside the packages and the configuration changed location as well. So we had to rewrite the modules that we used to automate our stack. And so still a problem of chicken and egg, but not only with the Puppet DB, but with a lot of other things in the stack. Or we thought, hey, you know, we've been starting to use Docker for some time to automate acceptance tests. Could we maybe use Docker to deploy the Puppet stack, and then we solve this chicken and egg problem by replacing all our Puppet modules that manage the stack itself with Docker containers? So in 2015, we started doing this. We started making containers, making Docker images for the Puppet server, for the Puppet DB, for Puppet board, and for other tools around Puppet, such as Puppet Catalog Diff, for example, which we had been using to automate tests, to automate tests on our code and check if branches are ready to be merged or not. One problem was, how do we take care of R10K, or the deployment? For this, we decided to use a webhook, but the webhook did not play well with scaling out the Puppet server containers. So were we going to use just a webhook or mcollective as well, or both? We ended up using mcollective to bring the glue all together and distribute the run of R10K, but it was not very simple. And then there was the problem of authentication breaks. How do we manage authentication? And in particular, this is quite complex because in the Puppet world, authentication is based on certificates. So how do we get certificates to all the containers that need to communicate typically with the Puppet DB? So we realized the complexity was quite great in the system. And actually by building the containers, by putting them together, by starting to, put the system together as Lego kind of, which is what you can do with containers, we realized the complexity of the whole system even better than we had before, and the gain we got from the modularity of the containers. So initially we made our own images with pretty complex entry points to generate the certificates, to edit the configuration, and still the case in Puppetware images, so the official Puppet images actually. But later on, when we switched to more complex ways of deploying the system, we're still using the Puppetware images now, and we still need to override them because we add some components that are not present in the base images, such as HARA YAML GPG for secret encryption, or OpenJDK11, for example, for better garbage collection for the Puppet server or the Puppet DB. So we're using the official Puppetware images now, but with some overrides for specific features that we want. So the first thing we did actually was take these container images, put them together in the most simplest way we could find, the most simple way we could find. So we used Docker Compose for some time, roughly 2015 to 2016, and we still have one stack that's running it and some clients that are running it. It was simple, it was flexible, and it allowed us to play with the container images, with the containers themselves, with options. We had quite a few upgrades, and we saw that it was very flexible. It was really great to upgrade one component after another without impacting too much the others, rolling back components. That was really great. However, we had no orchestration. There was no cluster. There was no resilience. If the machine that was running the stack failed, well, everything fell together. So we started to wonder, maybe we could start playing with orchestration. And we have a principle in the infrastructure team at Camptocamp, is that we like to eat our own dog food, like we say. Because the developers in the company hadn't asked yet for container orchestration, we thought, hey, it could actually be very good for us. It could actually be a great use case to start playing with container orchestration so that whenever the developers ask for it, we'll be ready to answer their needs. And in fact, the Puppet stack was kind of perfect for us, because at Camptocamp we have software that our developers develop that are based essentially on Python, Java, and we have a lot of PostgreSQL for the database. And it so happens that the Puppet stack itself has, well, Java, the Puppet 7, the Puppet DB. There's some Python if you use Puppet board, and PostgreSQL is used as well. So we thought if we can do this, then we'll be ready for the needs of our developers. So we looked for an orchestration system, an orchestration approach that we could use that wouldn't be too complex. Well, everybody was already talking about Kubernetes in 2016, but it looked far too complex for what we wanted to do at the time. And it was the first time we were actually deploying any application on a container cluster. So we wanted something more simple than this. So we settled for Rancher, and Rancher 1 was running Cattle as an orchestrator. It's not the case anymore with Rancher 2, which is essentially, well, just Kubernetes. So it was a simple approach. We could reuse most of the Docker Compose.yaml that we had been using locally on a machine, and it provided orchestration for us. So we could start having a cluster with several machines running Docker and start spreading our containers on these machines and have some kind of flexibility as well as security if one of the machines crashed. Had more resilience for the system. So we ended up with the schema something like this. There's more than just Puppet in here. We have like a GOG setup for the Git repository at the time, and some other services around. The Puppet stack is essentially the green and blue parts. And so in the green parts, what we have is that we have the Puppet CA, which is very central, and Puppet CA is set to auto-sign certificate using a PSK, essentially, as well as a little bit of logic in addition to this. So we could use auto-sign based on metadata in the cluster, which allowed us to sign certificates automatically for the different containers, so that if a container needed a new certificate, it could request a certificate from the Puppet CA automatically. Then the Puppet DB is also a very central component. It's accessed by the Puppet server, by the Puppet board, by catalog diff, and this is why they need certificates to access the Puppet DB. And then in this first version running on Rancher, we use mcollective with ActiveMQ for the RTNK deployments, for the CA certificate signing, for cleaning the certificates and nodes in the Puppet DB. So what we did is that we used, or we created when it was necessary, mcollective plugins that allowed us to control the different components of the stack using mcollective through ActiveMQ. This also allowed us to scale the Puppet servers. And what we did is that we had one RTNK worker attached to each Puppet server so that the code could be checked out locally for each Puppet server, and mcollective allowed to distribute the signals for RTNK to do the checkout wherever the Puppet server was running, whichever node of the cluster it was running on. And then the little blue part at the bottom is the Puppet catalog diff, which is a tool that we were using and we're still using to make diffs in production to see if branches are ready to be merged, and it needs to access the Puppet CA and the Puppet DB in order to do this, as well as a Puppet itself, the Puppet server. At the time, we had actually spread the Puppet CA and the Puppet server into two different containers, and so we had two access points, two routes, if you want, to access the Puppet server and the Puppet CA. And so we had a load balancer in front that would distribute between the Puppet CA and the Puppet server with different names. So we were pretty happy with the result. In fact, we were so happy with the result that we made t-shirts of it. And so we learned a lot from the Puppet component, from the interaction of the different containers, what was necessary for containers to share in terms of files, in terms of communication, and so on. And it was a bit like, taking a phone apart, looking at all the components and putting it back together. We knew how it worked, but spreading it into containers taught us a lot about the internals of the system. And then 2016, 2017 came, and well, it became obvious that Kubernetes had won the containers race, the orchestrator race, at least. I mean, even Docker wanted to do Kubernetes. So we needed to rethink our stack. And we thought, okay, let's move to Kubernetes. Let's start using it. And in particular, because we are Red Hat partners, we decided to switch to OpenShift and to try and port our Puppet stack to OpenShift. So for us, switching to Kubernetes was something quite logical eventually. A lot of the tools that we'd been using over the years, a lot of the expertise we had been building on these tools kind of ended up logically into Kubernetes and were ended up in this ecosystem that Kubernetes provided, and OpenShift in particular. There were some challenges, though, some important challenges. One of them is that because we were running on OpenShift, containers on OpenShift cannot run as root by default. You need to override this as an administrator of the cluster. And we didn't want to override this. We wanted to follow this rule. It was good practice as far as security was concerned. So originally what we started doing was to try to adapt the entry point scripts in the containers to run as non-root. But this was not very simple because it meant that a lot of files needed to have very specific rights so that the entry points could modify them. So eventually we got rid of the entry point scripts. We're not using them anymore. And we're just mounting the files as config maps or secrets in Kubernetes on top of the existing files. It's easier. On the other hand, it's not very flexible. And we need full configurations to deploy the stack, which means, for example, files like host.conf need to be provided entirely and not just patched. I'm still hoping, by the way, to integrate things like OGS into Kubernetes so that we can patch config maps in a smarter way. I don't know yet how this is going to happen eventually. So we use the Purple images with some overrides again, and we disable the entry points by running a specific command as non-root, and we replaced these entry points essentially by init containers in Kubernetes for autosign, for GPG setup, for GMX to get the metrics in Grafana and so on. One big challenge in containerization in general and in Kubernetes in particular is storage. How do you store the data? Well, the Puppet stack is a bit particular. It doesn't really have much data to store. There's essentially two volumes that are necessary. One is the Puppet code, and the Puppet code is kind of not a very permanent storage because the source of truth is not in the storage itself, it's in Git. So you need the Puppet servers to be able to access this code, and it needs to be provisioned in some way. It needs to be there and provisioned through the Git repository. So this Puppet code volume needs read-write access from the R10K containers, and it needs read-only access from the compile masters. And then there's the Puppet CA. The Puppet CA is a little bit more complex because it needs to be accessed by all the Puppet servers if we put the Puppet servers and the Puppet CA together in one block, which is much easier to manage than having the CA separated. And so for this, we need a read-write access. So we need some kind of thing like NFS or GlusterFS. At the moment, we're using NFS, which is not a huge problem considering that the CA doesn't really need to be very efficient. It doesn't need very speedy read or write on the file system. The CA could be regenerated from keys and certificates, but then we lose the inventory and the serial. So we want to avoid this. So in Rancher, what we used to do is that we would split the CA and the compile nodes. We would have one CA with a read-write once volume that would follow the CA container, and multiple compile nodes with read-only code and autosign, and then two routes for the CA and the compilers. In Kubernetes, what we've done is put everything back together. So we've got two read-write multiple volumes on NFS. It's slower, but it's easier to manage with one route that routes to all the Puppet server containers, and all the containers have access to the same volume. And R10K actually runs for us as a GitLab executor container with read-write access to Puppet code. So it's actually triggered in one container from GitLab instead of mcollective. So this was fine. We originally deployed this with Helm, and then we switched to Helm file, and now the trend is using Argo CD because it allows us to do a GitOps approach, which is much more Puppet-like in a way in a Kubernetes world, and we like this. So in Argo CD, this is what it looks like. This is the Puppet's namespace as deployed in our Kubernetes environment some time ago. So we've got a database, we've got the GitLab runners, we've got the catalog diff, Puppet board, Puppet DB, the Puppet server, and what Terra board is in there. It doesn't have much to do with Puppet, but it didn't have its own namespace. So we have one project with multiple applications in there, one application per component, and the GitLab runners for the R10K deployments. If we look at the Puppet server application, specifically in Argo CD, then you can see all the components that are deployed for the Puppet server, including the volumes, the PVCs, the services, the deployments, and so on and so forth. Because we've plugged GMX in our deployment for the Puppet server and the Puppet DB, we get metrics that are sent to Prometheus, and we're able to do Grafana dashboards. This is really great for us as we deploy in containers. We can have the visibility of the different containers as the services scale out. So typically, Puppet servers are scaled by 2 or 3 containers at a time, 2 or 3 pods in Kubernetes. And so we can follow the full load of the Puppet server service using Grafana dashboards. We're also using metrics that we get using the PuppetDB Prometheus exporter container, which is a full replacement for Vox Populai's report exporter for Prometheus. So instead of running a report exporter on the Puppet server, we have a container that plugs into the PuppetDB and gets metrics on a regular basis and sends it to Prometheus. So we're able to also have graphs for each of the nodes to see how the Puppet runs are going in Grafana. I'm hoping that eventually it might be a full replacement for Puppet board. Maybe one thing we're missing is the logs and the reports in there. I'm hoping that Loki might be an option for this eventually. We've also deployed the Puppet catalog diff in there, so we can run it inside GitLab CI as a pipeline step, and also see the reports in Kubernetes as they're served by an Nginx container. Finally, in the last few months, we've been working on replacing the certificate logic in the stack. So right now, as I said, we're using init containers for everything that is not implemented inside the containers. And so for like Puppet server containers, for example, we have an init container that will generate a CSR and then send it using Puppet SSL submit request. It sends it to the Puppet CA, and it uses a PSK to get it automatically signed by the Puppet CA. It works, but it's not really great. And the main reason is that we don't have a hold of the life cycle of the Puppet certificate, which means we can generate a certificate for every pod every time we need. But whenever a pod dies, whenever a pod is replaced, this certificate stays on the Puppet CA, cannot be removed, because there is no way for us to clean that certificate automatically like we do for other machines. So this is not really great. Also, it means that we need to deploy a PSK, so essentially give admin rights on different pods so that they can ask for certificates to the Puppet CA, and this is not really clean either. So what we've done is started working with Cert Manager, and Cert Manager is a system, it's an application that you can deploy in Kubernetes and will provide certificates for your applications. So typically it's got issuers. Issuers are the plugins that provide the certificates based on different CA systems. And it's got an issuer for Let's Encrypt, obviously, because that's what most people want to do. They want Let's Encrypt certificates for their web applications. And so we've created a new issuer that is called the Puppet CA issuer. And this new issuer plugs into the Puppet CA. So obviously it's got a way to plug into a Puppet CA. So it's got a certificate that can connect to the Puppet CA and submit certificates and sign the certificates and retrieve them. But it's only this issuer that has this right. And so what happens is if you create a certificate as a Kubernetes object, a certificate object, then Cert Manager will see the certificate. It will create a CSR based on this request and post a CSR object, a certificate request object to Kubernetes. And then the Puppet CA issuer will see the certificate request. It will read it, forward it to the Puppet CA, get it signed, retrieve a certificate from the Puppet CA, and post it to Kubernetes. And then the Cert Manager will take this certificate object and put it in a secret. It looks a little bit complicated, but the advantage of this approach is that it's becoming a standard for certificate management in Kubernetes. And so eventually with this, we can say, I want a certificate for this name with these additional alt names. And Cert Manager and Puppet CA issuer will work together to provide the certificate inside a secret, and then this secret can be mounted in any container you want, in any pod you want, through the simple mechanism of mounting secrets in Kubernetes. So we're hoping to go further with this. It's still missing something. I added recently, last week, I added certificate cleanup automatically. So now when you remove the certificate from Kubernetes, it actually cleans the certificate from Puppet CA. And what's still missing is custom extension support, so that we can have extension for all the extensions you can provide in CSR attributes, the YAML typically in Puppet for the PP environment, PP role, and so on and so forth, which we use quite a bit in our Puppet manifests. So this is a summary of information you can find on the subject. I've written a few posts on dev.to about specifically the metrics that we get from this and the benefits we get from Kubernetes to debug the stack whenever there's problems. And there's also GitHub projects with our Kubernetes charts, the Papa-aware projects for the container images, as well as some Helm charts in there, and some of the tools we've written to automate the stack Prometheus PuppetDB exporter, which allows to get the metrics from the PuppetDB and put them in Prometheus, as well as our pipelines in GitLab that are based on GitLab executors running in Kubernetes, and the most recent project, the Puppet CA Sure, for the certificate management. Thank you.